All right, guys, another form of compound interest is when interest is compounded daily. Okay, this is where your interest grows very rapidly. It's called continuous compounding. The formula for it is A equals P times E to the RT, where E is this irrational number, which is approximately 2.71828. It's an irrational number, kind of like how pi is. But so when you want to evaluate these, you have this E function on your calculator. So you would just press the E function on your calculator and use that to evaluate it. But again, this type of compound interest is when your interest is being compounded daily. So let's just look at a problem. It says suppose you have 15,000 to invest. Which of the two rates would yield the larger amount in 2 years? A 12% compounded quarterly or 11.91% compounded continuously. So on the left side here, we're going to do the compounded quarter, the 12% compounded quarterly, and on the right, we're going to do the 11.91% compounded continuously. So let's just plug in. So my P is 15,000. 1 plus, again, R is 0.12 for the 12%. Compounded quarterly, so that's going to be 4 times. And then that's 4 times 2 for my number of years. Alright, now we're just going to try to simplify this up a little bit at a time. So we have A equals 15,000. And then here you have 0.12 divided by 4 is 0.03. Plus 1 gives me 1.03. And then 4 times 2 is 8. Alright, now I'm just going to evaluate this out. And again, remember, because you're talking about money, you always want to make sure you round to the nearest cent. So do 1.03 to the 8th power. And then multiply that by the 15,000. And that's going to give us a total of $19,001.55. So that's how much money would yield if we did the 12% compounded quarterly for 2 years. All right, so now let's see the yield on compounded continuously. So A equals my original amount, which again is 15,000, times E to the R times T. Well, again, your R in this case is 0.1191. Okay, and then your T again is still 2 years. Alright, so really what we have then is we have that, excuse me, we have that E. Okay, so we have 15,000, and then we have times the E. Well, now that's raised, if you multiply those two numbers together, that's 0.2382. And now we just need to calculate that out. So again, you have that E function on your calculator, so you'll just want to punch that in, raise it to the 0.2382 power, and then just immediately multiply that by your 15,000. And what we find is that my A equals $19,034.44. And so if we look to see which one brings the larger yield back, it would be the compounded continuously. Alright, now we're going to look at calculating present value. So if you want to see, how much money do I need to deposit or in order to get this certain future value that I'm looking for. So your formula is your present value is equal to your future value divided by 1 plus your rate over n, which again is the number of times compounded, raised to the n times t, where t again is your number of years. Okay, so let's look at a problem. It says how much money should be deposited today in an account that earns 6% compounded semi-annually, okay, so that it will accumulate to 14,000 in 3 years. Now we know semi-annual, hopefully we know semi-annually means twice a year. Okay, so we have our formula, P equals A divided by 1 plus R over N raised to the N times T. Okay, so that's our formula. So again, we just are going to plug directly in. So we have P equals, we want it to get to 14,000, so that's my A. Alright, and then 1 plus my rate, which is 0.06 over n, which we said was 2 because it's semi-annually. And then raised to that 2 times the number of years is 3, so 2 times 3. Alright, now we're just going to start cleaning this up a little bit. And so we get P equals 14,000 divided by 0.06 divided by 2 is 0.03 plus 1. So that becomes 1.03 raised to the 2 times 3 is 6, so raised to the 6th power. And now we're just going to calculate that out. We have 1.03 raised to the 6th power. And then you're going to do 14,000 divided by that answer. And what we get is $11,724.78. And so, if you want to accumulate $14,000 in 3 years, you will have to initially deposit the $11,724.78 to get there.